Epicon tutorial.
Good day, listeners. We are considering the solution of nonlinear initial value problem by Homotopy Perturbation Method today. So we have the square y dx square minus y the y dx plus y square equal to 0 with the initial conditions y of 0 equal to 0 and y prime of 0 equal to 1. So the first thing we are going to do is to construct a homotopy for the differential equation 1. So the homotopy can be constructed as hp of y equal to 1 minus p y prime plus p into minus y prime plus y squared equal to 0. We are going to construct the power series for y written as y naught plus p y1 plus p squared y2 plus p3 y3 and so on. So substituting this into equation 2 and then equating by power of p. So we're going to have for p naught we have the 2y naught the x squared equal to 0, and with the initial conditions y naught of 0 equal to 0 and y prime naught of 0 equal to 1. Then for P1, we are going to have the 2y1 the x squared minus y naught the x plus y naught squared equal to 0 with the conditions y1 of 0 equal to 0 and y prime 1 of 0 equal to 0. So for p squared, we'll have the square y2 the x squared minus the nonlinear term is going to be treated as y1 the y naught over the x plus y naught the y1 the x, and then the second nonlinear term y naught y1 equal to 0 with the conditions y2 of 0 equal to 0 and the y prime 2 of 0 equal to 0. So now for p raised to power 3, we'll have the square y3 the x squared minus, so the nonlinear term is obtained as the y naught the x plus y naught the y2 the x plus y1 the y1 the x plus 2 y naught y2 plus y1 squared equal to 0. Then initial conditions can be written as of 3 equal to 0 y3 prime of 0 equal to 0. So other terms can be obtained. So to solve this, we begin with p raised to power 0, and that's the square y naught the x squared equal to 0, y of 0 equal to 0, the y naught of the x of 0 equal to 1. So this is y naught. So we integrate this once, and that gives the y naught, the x equal to 0 plus c1. Then applying the initial condition, the y naught of 0, the x equal to 1. This one means when x is 0, the y naught, the x equal to 1. So if we use that here, it means 1 equals to 0 plus c1. This implies that c1 is equal to 1. So we'll now come back here and make a substitution that the y naught, the x equal to 0 plus 1. This implies that the y naught, the x equal to 1. So integrating this again, we are going to have y naught equal to x plus c2, and then applying the initial condition, y of 0 equal to 0. This means that when x is 0, y is 0. So substituting that here, we say 0 equal to 0 plus c2. This implies that c2 is equal to 0. So if you bring back that here, so it means our y naught is equal to x. So this is the first term of the solution. So we pick the second one for p raised to power 1, which is this. To solve that, just like we said before, one of our videos. So we said that for all other terms, we discovered that the initial conditions are 0, 0. So applying the initial conditions one after the other will have no significant effect on the solution. So the best thing is to just go ahead and integrate the other two terms twice to obtain the solution, since the first term, y naught, has been determined. So as a result of that, we pick the second one, which is the square 1, the x squared minus y naught, the y naught, the x plus y naught squared. So this one, since our y naught is known, so we say the square 1, the x squared minus our y naught is x, g of x, the x plus x squared. Simplifying this, we'll have the square 1, the x squared. This is equal to 0. This is equal to 0. So we have x plus x squared equal to 0. So integrating both sides twice, we're going to have y1 equal to integral 0 to x of x, the x minus 0 to x, x squared, the x. Integrating this, we yield x raised to power 3 over 6 minus x raised to power 4 over 12 for our y1. So let's quickly obtain y2 as square y2, the x squared minus, so this is the nonlinear part, is written as the y naught, the y1, the x plus y1, the y naught, the x plus 2 y naught, y1 equal to 0. So solving for y2, we have a y2 equal to the double integral of 0 to x, y naught, the y1, the x plus y1, the y naught, the x, the x minus 2 integral y0 y1 dx. Like I said before, using the initial conditions here, we don't have any significant effects on the solution, so we just continue the integration. So making the substitution for y0 y1 and then differentiating y1 here, differentiating y0 here, and then integrating the two terms will yield y2 as 1/30 x raised to the power 5 minus 1/40 x raised to the power 6 plus 1/252 x raised to the power 7. So finally, we collect the terms together as y of x equal to y0 plus y1 plus y2. So y0, so just write few terms out of the solution as x plus 1/6 x raised to the power 3 minus 1/12 x raised to the power 4 plus 1/30 x raised to the power 5 minus 1/40 x raised to the power 6. So this is the solution of the differential equation. Thank you for listening.